Good morning, everybody. Welcome to another Builder Forum series. Today's topic is on the integrated design process, and we're going to talk all about what that is and what it means from our two great guest speakers. Today's event is brought to you by the Township of Langley Green Buildings team with a great deal of support from Sarah Maleska. And our presenters today are Larry Clay of Clay Construction and Nicholas Bell of Foxridge Homes. And a quick shout out to BC Hydro for supporting our event. In total, our Builder Forum series are fully sponsored externally, so we can provide this service at no cost to the township. And thanks to our sponsors, AIBC, BC Housing, PIBC, and BOA BC for recognizing our educational event as a meaningful contribution, and everybody who does collect those credits can apply for them. And as noted, Sarah Maleska is helping today, and as well, of course, we have our Gene Surrendon, our building energy specialist. He'll be taking us through our compliance corner. And if you don't know me, my name is Kevin Ramlou, and the Green Buildings Manager. Okay, on the menu today, we're going to start with some Township of Langley green building recaps. We'll follow up with the compliance corner with Gene Surrendran. We'll then go into the bulk of today, and it's talking about the integrated design process. We'll have Larry Clay talk about the IDP, what he does, lessons learned, and primarily he's speaking to all of you as a builder, as a peer. Take advantage of this opportunity, use the chat. We'll have some Q&A periods. Ask questions from builder to builder. We'll also then have Nicholas Bell of Foxridge Homes speak about his very, very impressive building that he's putting up here in Langley. It's a net zero home. We'll talk more about what that means and how he used the IDP to find himself being able to meet the net zero standard. And then we'll say goodbye. So I want to highlight, please take advantage of the chat. The chat is an excellent place to ask questions. The Green Buildings team can answer that as we go along, or others on the call, and as well as ask each other questions. This is the Builder Forum series. It's a forum for everybody to interact and engage with each other, and we find that there's a lot of meaningful dialogue there. So go ahead and use that chat box, and if you're having some technical difficulties, just let us know in the chat box, or go in the top right of your team screen and you should see a little chat icon, and you click that and off you go. Okay, so moving ahead, a recap of what we learned our last Builder Forum series, and that was on part 9 in the upper steps. We're targeting steps 4 and step 5 for part 9 buildings. In our last lecture, and Dallas Hordichuk gave us lots of really, really great tips and tricks and experience. He talked about what works for him to get to step 4 or 5, net zero energy ready, passive house, and some highlights. I have here, the full lecture was full of awesome stuff, and it is on our website to view now, but here's some tidbits. He noted the most common wall for him for a step 3 building was 2x6. R22 for a step 4, 2x6, 16, center R22 bat. And as well, I can't see this now, oops. The most common wall for a step 5 was 2x6, 24 center R22 bat. So here's some tips and tricks, some things you can try. He noted, and he really emphasized this, that surface area, or your perimeter, the perimeter of your building matters more than your insulation. When we take a look at the left image there, we have a perimeter of a building. It's rather complex, and on the right of it, it's slightly less complex. That building on the left, it's a bit hard to see, but that building on the left, when we simulate a large number of scenarios trying to get that building to meet step code, what we find is most of the scenarios land in a step 2, step 3, compliance may be bleeding into step 4. However, when we are a little bit more wise with how we use our perimeter, and it's still, this is not a complete box, it still has articulations, it still has a little bit of texture to its exterior, what we find is many of the simulations start landing in step 4 and bleeding into step 5 by virtue of changing how we use our perimeter of the building. He also notes some awesome tips and tricks, some easy tidbits, how to pass step 5. Air changes every time. He notes, first bullet here, mid-construction test every time, and I support that as well as we bleed into step 4 and 5. He notes, and this is a good tip, avoid pot lights and poly boots. Simple detailing, good quality control. He also notes, don't use spray foam. He gives an example of some perfect storms, a complicated shape and bad window position leads us to a very, very, very poor outcome. This home is rather complex. He has lots of windows on the north side, and thereby we're losing a lot of heat from the north side, otherwise the cold side. And this the simulation output here on the right shows it. I don't know how many simulations, but hundreds of them. What we see is, under no circumstance can this building even enter step 2. So thereby, if you design this house, no matter what you do, you will not meet step 2, and thereby not be able to build in any of the cities that have adopted step code. I want to highlight first, after all of our events, Sarah sends out shortly after a survey request. I want to say thank you to everybody over the many years that we've been doing the Builder Forum series for contributing to the surveys. They're very, very meaningful to us. It tells us what works, what doesn't work, what you learned, what's old. You know, you may already know this stuff. It's how we shape upcoming webinars. And I just wanted to highlight a few pieces from our last survey about what did you say? What did you tell us about what happened? Because it is a bit of a milestone for us. Starting at the left, some folks said that what they learned was easy collaboration is key to success. The last session was the best session so far. Another person notes an interactive nature of the presentation is great. It provides ample opportunity for questions to be addressed. Presenters were very knowledgeable about the content, thorough but concise, perfect balance. We're really grateful for your attendance and your feedback, and we're excited to say that for the first time, our last lecture, our last workshop, which did have our STEPCO consultation piece, 100% of those who took the survey were fully or somewhat satisfied with the lecture, and that's heartwarming to say the least. We're very happy about that, and it motivates us to continue going. 92% of the attendees increased confidence in building to the STEP code. That's a key figure we track. I think what the intention of tracking that number is if as this number goes lower, 90 becomes 80 and 70 and 50, and if we get a number that says, oh, only 5% of you have increased confidence in building the STEP code, that maybe means we can walk away. It means the rest of you have figured it out. We're here to help support you and help build confidence. And so this lets us know that you're learning something. We have a wide spectrum of people attending from a variety of industries. The gross majority makes sense as builders. We have a lot of architects, but also many others from a variety of competencies and parts of the building process. And we also collect constructive feedback. There's a note for more education for tradespeople. Great note. More information on how to claim educational credits. And somebody noted it's hard to follow sometimes the technical terms. Ask, and if you have if you have questions as we go along, go ahead and put your question in the chat. Somebody will be happy to answer.
Hey, Kevin.
Yes.
I noticed we had a couple people with their hands up, I think.
Oh.
But they put their hands down, so maybe they don't have questions anymore, but there are a couple questions in the chat. So I think a couple slides before you mentioned spray foam. So someone asked, why not spray foam?
Okay, good. Maybe let's I'm gonna finish up my recap, and before we go to a Jean, we'll spend a couple of minutes for some questions. And just because you've already highlighted that, Sarah, so spray foam, as per the last lecture, Dallas noted that it's it's not as potentially as airtight as once thought. And what we saw in the last workshop, and you can go to our website and find our last slides and actual video presentation. You can play it for yourself. He found through infrared testing that there was heat loss. It just wasn't as airtight as what many had thought, and that's what we learned last time. So this is a big piece. Our last workshop included step code consultation, and we made a rather large and lengthy point to please provide feedback, commentary, and consultation. Talk to us. This is your opportunity to talk. And so I want to highlight, thank you for your input. The proposal is as in front of you. This is what you saw a few months ago during the workshop, that we are proposing to incorporate Part 3 office and retail or D&E occupancies to our step code framework. We're going to proposing to start at step 2 in 2023 and a step 3 or final step in 2026. We also note that through a great deal of analysis, we've identified small buildings, and this is as in that box there on the top left. If you are under 2,500 square meters and 1 story, you are exempt currently from the step code framework. And this is primarily for Part 3 builders. If you want to talk about that more, give us a shout offline. For Part 9, for single family dwellings, duplex, triplex, townhouse, and row house, we're proposing step 4 starting next year. And lastly, Part 3 A and B, this is sometimes called institutional buildings, but otherwise assembly and B type buildings. We're proposing entry and step code at step 1 next year, or whatever shape it takes. There's some details about in-stream or what's going on if you already have a DP. We have provisions for that. I'll leave that there. That's what we proposed the last session. So summarizing our consultations, consultation began in 2021 and continued into 2022. June 28th was our last workshop, where we went through the entire proposal. So I'm going to highlight now the feedback that we got back. Input was actually quite generally, the majority of feedback was actually neutral. We asked a question in our survey saying, do you have any thoughts, comments, concerns, or anything like that? And it was an open-ended question. The majority of answers were simply, no, we have no feedback. So therefore neutral. The comments we did have on either end were around timing. It wasn't, we didn't get really any feedback around the framework, it was around timing. And the feedback that we got was, there was a small handful of notes saying speed up. We're not going fast enough, is what they said. And there was a smaller handful of folks that said slow down. We've evaluated all the feedback that we have received, and we note that the proposed schedule that we had offered in June is that it's right down the middle. Therefore, the framework as presented will be retained, and we are anticipating proposing this to council this year. Okay, with that, I'll take I can't see any the chat box or hands up or anything like that. So Sarah, I'll lean on you. If there's any questions I can answer now that are good for now, I'll take them now. Otherwise, we can move on to a June.
Perfect. Yeah, there were no more questions, just some chat in the chat box answering why not spray foam. So Natalie said that it's not as airtight and there's lots of embodied carbon emissions in spray foam. Yeah. And Nicholas Henderson said when buildings shrink and settle gaps form between the spray foam and the framing, spray foam does not flex with the building. All those gaps add up to massive air loss. Also, there's often issues with installation and many thin areas. So that's great, the update from the chat.
Great, thank you, Sarah, for highlighting that. Thank you, both Natalie and Nicholas for highlighting. That's great, and Nicholas, that's awesome. You note that while it may work for getting your building permit, for example, if you didn't have any air leaks, but yeah, who knows? 1 year, 2 years, 3 years, 4 years, you're just simply not performing as expected. So that's great feedback. Thank you for contributing. Okay, with that, I'm going to move it on to our compliance corner with Jean. Jean, there you go.
Yeah. I've
And
just
here
requested control.
Yeah, there you go.
Okay. Good morning, everyone, and thank you, Kevin, for the brief update. I just want to. um, Okay, yeah, it's working. So, I mean, we just like as many of you already know, like we have a BC building code uh, proposed updates that's coming up, and so now that like they are right currently on their consultation phase, so I thought like we should be just summarizing some of these updates and for you so that it's easier for you, and then you can go and give your feedback. So now this is going to be a very high level summary, and we are not going to get into the details, and we recommend you to go and like read the updates and then provide your feedback. So now, if you have any specific question regarding some of those code languages, I think Building Safety Standard Branch is the right place that you have to contact. So what we, so yeah, now towards the end of my session, what I'm going to do is like going to give you the link where you can find what are the updates and what are the how to provide your feedback. So I'm going to give you the links. I'll be posting them in the chat box. Key updates: 6-week public consultation. So they're currently in like fourth or fifth week, I guess, and the consultation ends on 4th of November, which means next week. So so yeah, you have very less time, but please do make sure you have a look at those updates. What are the key updates? The minimum performance in general, like they are elevating the floor, like a minimum performance requirement of 20% better than the current code. Now they are introducing a Part 9 prescriptive pathway and a carbon pollution standard. They are also planning on not planning like they have also included languages that's consistent with the national building code, so it's like more like a harmonization between these two codes. So coming to part 9 update. So there is like part 9 and part 10 of BCBC. So part 9 represents the part 9 buildings, and part 3 represents part 10 represents the part 3 buildings. The major updates to 9.36. I know most of you might be familiar with this, and because I mentioned earlier, like the 20% minimum is the new floor. So now step 1 and step 2 are now reserved. So which means you cannot use them for compliance. And step 3 will be the minimum standard. Now, I would also, I mean, this is also like a new prescriptive pathway is also available, which is equivalent to step 3, and this is available province-wide. And this is more like, if you are familiar with 9.36, you should be knowing like, 9.36.2 to 936.4. There are some tables and minimum performance requirements. So these performance are now increased. Another note is like reformatting. So when you are reading the code updates to the code language, you can see the percentage better than the ERS being stroked off. So this is not, it doesn't mean that it's been removed. Like we had some confusions there, but it's just moved to a new table. So it's just reformatting so that it aligns with the national building code. As I said earlier, a new carbon pollution standard, and you can see in this new section 937, which is named as greenhouse gas emissions. It is very similar to the beginning of step code, where the local governments can opt in to a specific GHG emissions level, like step 1, 2, 3, 4. Here you have measure only, medium, low, and zero carbon ready it is. I'm sorry for the typo there. Uh, you might be familiar with GHGIs. So the new code can also proposing GHGI and absolute GHG compliance pathways. So because for this mainly for like smaller buildings where you cannot meet the specific GHGI targets. You will be able to meet the GHGs because it's already too low to begin with. Uh, similar to the part 9.36, you also have a prescriptive pathway here, which is mainly dealing with like prescribing the mechanical systems that you use in that you use in your building. This is how the table looks like. I'm not going to get into every details. I would recommend you to go through the details by yourself and read about it. So you have like there's a base GHG emission, there is a maximum GHG emission, and then there is also the prescriptive path. So those are the three columns that you see here, 1, 2, and 3. Coming to the proposed updates to part 3, uh, as we said earlier, 20% improvement means step 1 is now reserved. And so what does that mean is like step 2 to 4 are applicable for group C, which is residential occupancy, and then step 2 to 3 is applicable for D and E, which is business and mercantile occupancies. There are some updates to the TUI targets, the TUI metrics. So they have reduced the metrics. It's mainly because their modeling showed that it should be reduced, especially for D and E. So have a look at that too. So for future. GHG, carbon pollution standard, opt-in, again, measure only, medium, low, is very similar to part 9. And here they don't have a absolute GHG because it's like too big. So people who are familiar with other local governments, they have the 631 GHGIs. This is very similar, but their modeling study showed that and based on their modeling study, these are the results, like these are the targets they're proposing. So that's those are the major updates. Now this is the link, like if I'll be posting them in the chat box too, so you can go there and like have a look at those links. They have done a pretty good job, because for example, so this is what you're going to see there. Like when you scroll down, you'll see all these different links. So the first 3 links are the proposed code languages. That's how the code is going to be. They have also provided a summary presentation, like videos on YouTube, where you can see them all where it's a summarized version, but you can know in bit more details, like what are the changes. You can also, if you're interested, you can also look into the metrics research report, which was the study conducted by the province that resulted in the proposed updates. There are also like financial and technical analysis being posted here. So please have a look, and when you scroll down, you will find this section, which is provide your comments as part of the online review. This is like a survey based uh, it's like a survey, so survey based feedback mechanism. So read the code language, provide your feedback, and yeah, and the last date is November 4th. So that's the end of this public consultation. I mean, the code updates. I do have one more item on my list. Uh, okay, now regarding the code updates, I would also recommend, like, if you have any questions regarding the code, we would recommend you to call, like, contact BSSB, Building Safety Standard branch, because yeah, they will be in a better position to answer those questions, the code specific questions. Moving on to the last session that I have, this is more like a reminder for the energy advisors. So, and also for the builders, you can say, because when you're applying for building permits, uh, to avoid like further delays. So the thing is, modeling building components only if they exist in the building at the time of the application. So if you don't have something, or like if it's been proposed for the future and it's not been part of the BP, do not model it. And if there are like some future owner driven design changes that shall not be considered as long as it is been finalized. The reason why we are saying, like, I mean, the reason why we are saying this is we have been seeing a trend in the building industry where the builders offer the future owners as air conditioners as an opt-in feature for the future owner. So what happens here is that the designers might even design the mechanical system and put them in the drawings, but it's not being installed, or it might be installed in the future based on what if the owner pays for it, but it's not at the time of the BP. So if air conditioners are optional during the design phase, this should not be modeled. And if it is not installed at the final, uh, do not model it. Now, if a part of the building, for example, you have a four unit townhome and two of them are with air conditioners and two are not with air conditioners, look into the area. If it is more than 50%, use the targets according to the area, the condition area of the building. This is as per BC building code. The MUI target should be based on the area of the condition area. So that brings end to my presentation. Uh, any questions? Yeah, if there's any questions, I don't see anything on the chat.
We have nothing in the chat yet.
Right. Yeah, if there is anything on the chat, like we can keep moving on. Like if there's anything on the chat, I can answer that.
Thanks, Jean.
Okay.
Thank you, Ajin. I'm gonna take control back.
Yeah, I did that already.
Okay. Is this
Yeah.
me now? Oh, it is me. Okay, and thanks, Ajin. And again, I want to really highlight and emphasize to everybody in the call that as Ajin has highlighted and described, the province is in a consultation phase for their updates to BC 2018 version 4 leading to version 5. So there are meaningful changes as Ajin has highlighted. The link is in the workshop slides. It's going to be maybe Ajin, if you could put it in the chat, or Sarah as
Yeah,
well.
I think Sarah already posted that.
Okay, great. So it's there. I want to encourage you all, if these BC changes are going to impact you in any way, shape, or form, I suggest you understand them intimately. And if you do have feedback or comments, this is your chance to participate in consultation. I've submitted my feedback about my thoughts on it. Everybody, green buildings, etc., will be doing that as well. So I encourage you all to take advantage of this public opportunity. And as well, and thanks, Ajin, so much for the compliance corner around that really unique, interesting case of pre-sale and options that include an air conditioner. That's an interesting thing that I think a lot of people, and it makes total sense that they would not be thinking about that really deeply when they're modeling and trying to get through this building permit process all the way to occupancy. And I think these are really interesting things that emerge as we move forward through step code. And this is a hurdle, or a potential hurdle for those who didn't know this. And thank you, Jean, for now educating us on this. That would have otherwise resulted in a delay of your building permit, or at least occupancy in this case. So now take advantage of that and ask your EAs. Did you see a Jean's compliance corner in October? If you are doing pre-sales with the potential for if you already have rough ends and the potential to add a condenser or not, that's really important. Jean's notified you if it's not modeled correctly, there will be delays. So please take advantage of the lesson that Jean's provided. And as well, for everybody in the call, we do host all of our workshops on our website. So go ahead and take a look at them. There's slides, there's videos, etc. You could always look at the compliance corner. These are easy tips and tricks to avoid delays. Okay, I think we're ready to move forward to the exciting part of our workshop today, and that's on the integrated design process. We've highlighted, and many of our speakers, builders, consultants over the last Many workshops have highlighted the integrated design process, albeit just kind of notes or encouraging you to look into it. Mark Bernhard, in a couple lectures ago, said integrated design process, it's cooperation for building professionals, and that's what it is. It's actually just having dialogue with each other. I know it's a little bit more than that, and we're going to learn more than that, and as well as we're going to learn why that's really, really critically important as we enter steps 4 and 5 in part 9. Steps 1, 2, and 3, they were designed to be an entryway into step code. Some really not even potentially targeting step 2 or 3 may land there, but as we enter steps 4 and 5, you need to do some effort, and you want to avoid pitfalls, avoid challenges where you need to do kind of design retrofits 90% through the design or construction process. The integrated design process is something that can help you from the outset. And today we have Larry Clay of Clay Construction. He's the founder and president of Clay Construction. He's the 2022 Custom Home Builder of the Year, and you may recognize him as the past national president of the CHBA. And as well here in the township, he was the builder for our first demonstration home project for our first large-scale step code home. So please welcome Larry Clay to the Builder Forum series, and we're going to learn a lot about the integrated design process. And as noted earlier, please take advantage of the chat box to ask questions as we go along. Hey, Larry, are you with us?
Yes, thanks, Kevin. Should I share my screen now?
Please.
Can you see it?
Yes. Yeah. it
Excellent.
looks
Good. Wonderful. Thank you. Yeah, thanks, Kevin, for the introduction. Yes, I'm Larry Clay, founder and president of Clay Construction. Now, like many of you, we are custom builders and renovators. I started building in the 1990s while I was teaching at Langley Christian School. In fact, I see a couple of my former students are online here. I eventually left teaching to become a builder and thus starting our business in 2003. So I come to you as a builder and I deal with the same issues as the other builders and renovators here. I'm trying to build a quality product, keep my clients happy, and at the end of the day, need to make money. I am not a building science expert, but I share my experiences as a builder like you trying to implement the BC Energy Step Code. So this is typical of what I build. That house, previous house, was in Westminster. This is in Vancouver. Another modern house in Vancouver, Burnaby. And this is the demonstration home that we partnered with the Township of Langley. And another home we built recently on a magnificent acreage here in Langley. But when I started building while I was teaching, construction was pretty simple. In fact, this house here is the first house that I ever built while I was teaching. I found a stock plan, I liked it, and I applied for a permit. This was the first house I built. And essentially, trades did what they always did. Any decisions that we made were not done at the design stage, they were done on site. Trades worked in their own silos and essentially did what they always did, and there was little need to interact. The framer framed, the HVAC contractor installed his preferred furnace and used a rule of thumb when determining the size of runs to each room. HRVs were never needed because our homes leaked enough that air quality was not questioned. The insulator insulated, and since there was no performance testing on the homes, quality mattered little to most, just past the inspection. We always used batten poly for the entire house. The siding contractor used tar paper, and we had no rain screen. So I built that way in the 1990s, and 30 years later, many still build this way other than tar paper and rain screen. But times are changing. As builders, we must be changing with the times. Running a successful business, clients are relying on us to be professional and up to date, understanding the latest advancements in building science, energy efficiency, and better building practices. They are trusting us to build their home to the latest BC building code, including the BC Energy Step Code, and have no short or long-term issues with performance, comfort, and durability. Our homes are becoming more airtight. We are adding more insulation. The wall assemblies vary greatly. We are adding HRVs and ERVs, and windows are improving continually. With the BC Energy Step Code, we are going to be building more energy efficient homes. They need to be affordable, thermally comfortable, healthy, sustainable, efficient. So how do we get there? We don't get there by accident. We get there as a planned event. So a question for the builders. Do you ever worry that this new wall assembly might trap moisture? Remember the condo crisis in the 80s. Or the heating system is not sized correctly, resulting in intrusive corrective measures that will be expensive to fix. Or other warranty work that will result from new wall assemblies or space conditioning decisions. I can tell you that this is always a concern I have. When homeowners are living in the house, this is a cost prohibitive nightmare. IDP, or integrated design process, is really front loading some of the decisions you'll be making later on in the process anyways. It's a collaborative design approach intended to optimize the performance, cost, occupant comfort, and resilience of a residential building. It involves engaging the builder, the architectural designer, mechanical contractor, insulator, window manufacturer, energy advisor, and others as needed at the conceptual stage. Remember, we have to treat the house as a system because we know that the more airtight we make these buildings, it's going to affect the heating system, more insulation, better quality windows. We need to be talking with each other and making sure that we're planning in advance a home that will function well. So who's part of the team? Well, I'd say the first batch that you'd be considering would be the architectural designer, homeowner, builder. That's where you start. But there's an energy advisors, engineers, if they're needed, HVAC contractor, window supplier. And there's a second batch. Every home is different and they have different requirements and needs. For example, the solar contractor might be an important part of a project. And if a solar contractor is needed, be looking at roof orientation and roof design for net zero. But if you're planning for net zero ready, it's wise to start considering these elements now. It might be better to have a gable roof and not a hip, for example. And make sure you're concerned with plumbing vents and roof vents. I see we have Wally Martin on the line, and he also would have lots of thoughts on this, and I would reach out to him if you have any questions about this. Now, I'm going to turn.
Process is so important, and Peter was sharing with me what they learned by putting solar panels on this house you see over there. Had this process had integrated design, they would have realized the plumbing stacks and the roof vents needed to be moved to the other side of the roof so they would have more surface area for the solar panels. So Peter, tell us what you learned.
Well, we learned that we should have had the solar guys at the table and reviewing our drawings early on. What happened was that they were hired late in the process, and we're kind of stuck with the roof vents in the way when it would have been a piece of cake for us to have offset them to the other side of the roof.
Ultimately, what they should have done is put all the plumbing vents roof vents on the northeast side of the roof. And I'm going to show you a roof right now where they did that properly because they learned this after the first time.
Here you can see the roof where the roof vents and the plumbing jacks are coming out on the north side of the roof, which is perfect, allowing the south side to be used for the solar panels. So Peter Amarongan is a high performance builder that I see at national meetings with CHBA, and he has been building high performance since the 1990s. And I hope you guys were able to, I hope you're able to hear that. So while every home might not need solar at this point, it might be prudent to start planning ahead. Someone will thank you in the future when they attempt to install solar. And I recognize that homes that have street views that face north may not want to place all of their vents facing the street, but at least at this point, it's something to be discussing and considering. So there's 5 things. This is my list. It's not intended to be exhaustive, but just an introduction to IDP. It's my list of the considerations that will give you an idea of the items that you have to consider during the design process. It is not intended to be exhaustive, but is an introduction. First of all, when we're meeting with homeowners, we really have to consider what's important to them. They may want to go for step 5 and we're only needing step 3. We need to respect that. They may say, I want flat ceilings and no drops, or large windows to take advantage of the ocean view that they paid for. They may have preferred design styles. They might need to have a healthy home, or preferred heating, cooling methods. I have to have radiant heat, air conditioning, or they may have a preferred wall assembly like insulated concrete forms. These clients discovered the benefits of insulated concrete forms and had asked us to do the basement with insulated concrete forms. Now, I had another client in Point Grey. They also wanted ICF, and you can see the ICF on the bottom there. But they wanted ICF all the way up to the trusses. The homeowner came to us and said, with a set of plans, and said, we want ICF to the trusses. So we sent the plans out for engineering after the plans were complete. And it was determined that the beams would have to be steel and it would be spatially prohibitive. They're going to be way too large and the cost prohibitive. So he needed to eliminate the ICF on the upper 2 floors. But he wanted ICF. Had our client involved us earlier, the structural engineer would have been involved earlier, and we would have changed the design to stack the walls on top of each other. So there's an example of where integrated design would have helped the homeowner get what they want. Number 2 is step code required. In BC, the minimum step will be step 3 by January 2023, but we're aiming for step 5, 2032, as most of you would know. While many are meeting step 3 with 2x8 walls, this is not scalable to step 4 and 5. We will need to learn how to install exterior insulation. I personally like the perfect wall. If you've heard of Joe Stebrick, go to buildingscience.com. Marvelous man. He has promoted the perfect wall. And essentially, the perfect wall has exterior insulation and no insulation between the studs. If you put insulation between the studs, we call that a split wall. But you put all of it on the outside, it's called the perfect wall, as Joe Stebrick has promoted it. So if you need to design build at a higher step level, let me share with you something that I learned. Now, if you forget everything that I've told you, pay attention to this slide and the next slide, because this is the crux of what I really want to communicate in these 2 slides. So initially, you can see the house here, very simple house. I was asked to build a net zero ready home in Burnaby. Our energy advisor modeled the home, and we needed to do the following, which you can see: 2 inches of rigid XPS on the outside, 2x6 split insulated wall, triple glazed Euroline windows, 1 air changes. Foundation was insulated concrete forms. We had an effective R29.5 and R12 under the slab with an HRV. So that was what we needed to do to get that house to net zero ready. As you can see, it's a pretty simple house. So I was asked to build a house in Langley, and they wanted a luxury home. We started the design process, and I asked if they would like to have a net zero ready home. And he replied, yeah, that'd be fantastic. So during the design, we assumed that we'd use the same requirements on the Langley home as we did on this home you can see on the slide. And then once we got the plans done and it modeled, we would tweak as necessary. A little more insulation, a little better windows. We'll tweak it as needed. And so far, so good. This is an approach many builders would think would be appropriate. So here's the house. This is the house that we ended up designing. And the energy modeler modeled it. And we didn't even hit step 2. We modeled with the same elements on the previous house. This house did not hit step 2. But here's the point. Had my clients demanded step 5, I'd be in a difficult position. We would need to redesign the home, causing delays, increased costs of the delays, and disappointed clients who have already fallen in love with the design. At this point, the homeowner would have lost confidence in us and potentially ended the relationship. Since net zero ready was not required, we push on with this home with the design as you see it, with no delays. So that's really, I'm going back to the slide. You can see what was required for this house is very different than what we needed for this house. Design's going to be critical for us to hit the step code. And we may be needing to change the design, simplify, changing orientations, looking at how big the windows are on different elevations, but we need to be doing this early. Thus, we need to get that energy advisor in early. And if you're doing passive, you want your PHPP to be run on the home or Hot 2000. Consideration number 3 is going to be cost and affordability. That's always critical to our clients. We have to be protecting affordability, and we got to be clear what homes will cost. So here's a house that we built in Vancouver. This is before step code, and I was asked to speak about the cost to get to step 5, which I did at a previous seminar with Township of Langley. And this is what I found. I modeled what was needed and to get to step 3, 4, and 5. And you can see $48,220 to hit step 5 for this house, the way it was modeled over top of the code at the time, 2018 in Vancouver. So what I discovered was it was $48,000. I was sharing this with a builder in Newfoundland, Greg Hussey, who's our national treasurer. And he says, Larry, there is absolutely no way this would fly in Newfoundland. I was a little confused. I asked why, and he says, we sell our homes for $220,000, brand new homes, house and lot. There's no way it would kill construction if we had to add $48,220. So I was shocked. So I was talking to our past president, Eric Denowden, and I shared what Greg said. He says, it's the same thing here in Ontario. He lived in a small town in Ontario, and he says, we sell our homes $290 house and lot. So affordability is important. Operational carbon has been the focus and will continue up to 2032. But just be aware that embodied carbon is important as well. And you're going to be hearing much more about this in the future. The meetings that I'm heading to with the CHBA, embodied carbon is a lot of talk right now. You'll be hearing a lot more about it. So on the subject of affordability, it's too many homeowners are designing homes they can't afford. And let me share one reason why this is happening and how, as builders, we can help fix this. If you ask 6 different builders, you'll get 6 different answers. What is your cost per square foot to build a house? Well, of that list you see there, who's the cheapest? Well, we don't really know. We don't have enough information. But that's often the first question I get from potential clients. There's no agreement amongst builders in what should be included on the price per square foot number. So about 5 years ago, I priced out a home. Ignore the outdated pricing. That was 5 years ago, but the principle still applies. We priced out a home for $333,000 or $333 a square foot. Many other builders would say that they could build cheaper. Is it true? Maybe. But we just don't have enough information at this point. Just saying 333 or 250 is not enough. And I had builders say, yeah, I could build that for 275 or 300. Are they cheaper? Again, we don't have enough information. So if I decided to not include appliances and installation, I would take that off, and I just dropped my cost per square foot to $325. And landscaping, let's eliminate that, and now I'm down to $314. And demolition, asbestos testing and abatement, window coverings, taxes, and soft cost, because engineers or architects will come to me with a set of plans, and they said it's coming out of permits in a month, and so they're getting some prices. I don't include all the following soft costs: building permit fee in Vancouver, design fees, structural engineer, interior designer, COC insurance, energy modeling. Well, I'm down to $271. I'm practically free. But am I cheaper than the other guys? Maybe. We just need to make sure we're including in the scope of work the same elements. So homeowner goes to builder A, $333 a square foot, builder B, $271. Who's correct? Well, they're both correct. We still have to define what is going to go into the number. Builder B is only pricing out the cost to build a house. Builder A is really pricing out the entire project cost. And I suspect most homeowners are expecting project costs when they ask us for the cost per square foot to build a house. And so here's the problem. The homeowner has a budget of $1,355,000. They talk to builder B, who says he builds for $271 a square foot. He says, well, then I can then build a home 5,000 square feet. Great. So he designs a home for 5,000 square feet. And then he goes out to other builders who are now giving the whole project costs. And he finds that it's gone up to $1,665,000, which is a $310,000 difference. He can't afford that because the homeowner thought when builder B said $271 a square foot, he was including all project costs. So this is something we have to be more clear on with our clients. So number 4 would be building science to govern decisions. We have a lot of decisions to make. Where is your air barrier, or as Joe Stebrick would say, your air control layer? What methods, products are you using to achieve your air tightness? Most common is going to be the interior poly sheeting, but gaining popularity is the exterior air barrier. Some like the ADA approach, we have done taped plywood, we've done taped XPS, EPS, and GPS. We've done spray foam, we've done combinations of these. The vapor control layer, is that the poly sheeting? Smart vapor retarder, which is becoming our favorite, to use a smart vapor barrier. Paint on vapor retarder, or paint our vapor retarder onto the spray foam. Wall assemblies. There's a whole host of wall assemblies. A 2x8 R28 bat seems to be common amongst many. I like the 2x6 split insulated wall. That's going to be bat with some exterior insulation. They're perfect wall where all insulation is outboard using EPS, XPS, graphite infused EPS, or rock wool. Many of these we like. We do have our preferences though. Spray foam is used, SIPS, ICF, double stud wall, all options that we have. And we have the same with roof assemblies. We just did a house in Shaughnessy where we did the inverted roof, which is the perfect wall, inverted, all the insulations on top. And that was a fantastic process. Space conditioning, you know all the options, but we have to be considering these so that we can deliver a comfortable home to our clients. So how do we meet BC Energy Step Code, ensuring that our homes are the following: affordable, durable, resilient, comfortable, healthy, and with no unintended consequences? That is the challenge we have. And lastly, as we consider all of these options, we need to protect our clients from unintended consequences. Wetting risks. We need to understand vapor retarders and their location. We need to understand which wall assemblies do not dry very well and understand where the dew point is in the wall assembly. The purpose of this seminar is not to make you aware of every element and teach you building science and dive into details. Instead, we just want to make you aware that we need to understand the building science, understand how do we arrive at our goals with no unintended consequences. Mark Govin built a test hut on top of his building. This was in Austin Avenue in Coquitlam. I see we have Steve Riley on the line, and I'm sure he's been to this test hut probably several times. It's been taken down, dismantled now, but that happened probably about 4 years ago. So what Mark Govin did is he worked with Joe Stebrick, and he built this building on top of his office on Austin Avenue. And he had 7 wall assemblies, 3 roof assemblies. You see a full weather station, but he did the same wall assemblies on each elevation. And there you can see Joe Stebrick in his younger days, and he's been involved. And here's the wall assemblies that were used. And what he did was he tested each wall assembly with wetting apparatus, tested the relative humidity, the temperature, and they analyzed the durability of these wall assemblies. And millions of pieces of information went to Joe Stebrick and I think the University of Waterloo. And in the end, the conclusion really supported the value of exterior insulation. One of the unintended consequences of walls that don't dry is going to be mold and mildew. And this is one of the reasons we have stopped using poly in basements. Probably about 8-9 years ago, we stopped using poly. If I do have to use a vapor retarder, I will use a smart vapor barrier or vapor retarder. So improperly sized heating cooling equipment will result in decreased life expectancy of that equipment, inconsistent heating and cooling, and initially the equipment will be larger than needed and costly. and will result in homes that are uncomfortable, costly to replace, and unhealthier. It's one of the unintended consequences. So it's critical to have the HVAC contractor complete a heat loss, heat gain calculation. Need to determine the BTUs of heating and cooling per room and the equipment size. Now, this is a fairly lengthy process, taking 8 to 10 hours, but it requires accurate input from the builder, like air tightness and window specifications. And this is one of the biggest challenges of HVAC contractors, is to get accurate information. Essentially, garbage in, garbage out. So it's important as builders we give our HVAC contractor the right information early, and this is all part of the integrated design. So what does garbage in, garbage out lead to? Improper heating and cooling cycling off and on quickly, larger than necessary ducting, rooms that have vastly different temperatures, and you can read the rest. Ultimately, the homeowner will be more uncomfortable. Here is a slide of what it looks like. This is the TECA F28012 heat loss, heat gain calculation. And this is what you should get from your HVAC contractor. And I would be making sure that your HVAC contractor is doing this for every house. True story. This is a house built, it was in North Vancouver, 3.5 years old. I did not build the house, but they had low-end windows, but the source of the issue was minimum ventilation. And once the ventilation was improved, this went away. And why somebody would let homes get this moldy, I have no idea. But that is when I was called in. So I'll just mention as well, Part 3 buildings that are greater than 600 square meters or 6,458 square feet. That would be Part 3 buildings. They are more complex and consists of buildings like churches, hospitals, or residential care facilities, and they serve the public. IDP is regularly used by consultants in Part 3 buildings, and that's a bit of the difference between Part 3 and Part 9. Part 3 is already doing this. I wanted to share some of my favorite links. You can see Joe Steebrook right there. If you want to learn about building science, this will be a lifetime of reading at buildingscience.com. There's the perfect wall that I've been talking about. Green Advisor is wonderful. On Instagram, the Building Science Fight Club, Christina, I believe she's Joe Steebrook's daughter, does a fantastic job of videos and teaching. We often mention this stuff on our social media, where Instagram, LinkedIn, certainly follow us. And Construction Instruction, Gord Cook, Mark Laliberti. If these links don't work, just I put down on the bottom, if you highlight the link, you right click, choose hyperlink, open hyperlink, and that will bring you right to the web page. And a second page, CHBA's net zero. CHBA BC has more information on the net zero qualifications. If you didn't know, there's a building code 2018s for free. If you click on that, that'll give you free building code online. And there's additional reports from BC Housing. So key takeaways: get your energy advisor involved as early as possible. We're now at step 3, 4, and 5. We need to be doing that. Homes are becoming more complicated. We have to treat the home as a system. Ensure your HVAC contractor is completing TECA's F28012 heat loss, heat gain calculation. Be abundantly clear on budget numbers, what is included and not included, and deepen your understanding of building science to guide you in the best choice of wall assemblies, roof assemblies, and space conditioning approach, so that we can eliminate these unintended consequences. And that concludes what I need to say. Thank you.
Great.
Thanks so much, Larry.
Larry.
That was really great.
Go ahead, Kevin.
Yeah, thanks so much, Larry. That was awesome. A lot of great experiences and stories, and even went into some of the nitty-gritties of flirting with building science, and that's great. And I think we'll open up the room to questions. Sarah, do we want to open up, or can we? I'm leaning on you for this. If we can open it
Yeah.
up to like live questions, and with
Um,
question, or at least with this hands up feature. Maybe that's probably the best way to do that, so we can go in order. Or I'll leave that to you to highlight.
Yeah, that sounds good. If anyone has a question that they want to say out loud, just put your hands up and then I can unmute you. Also, I guess we have the question from way back at 9:19 a.m. from Paul. So this question was about spray foam and just kind of asking Larry what your general, I guess, opinion on spray foam is.
So my opinion on spray foam would be it's a bit mixed. There's mixed messages out there. We have used it, and we've done a renovation where we looked at the spray foam, and I was actually surprised. I was anticipating slight cracks on the exterior. I did not see it. Now, I did not use a heat gun. I am concerned about embodied carbon. So moving forward, this is going to be something we're going to be starting to look at is what products have more embodied carbon than others. And so embodied carbon does spray foam does not do well on the chart of embodied carbon. There's other products I would consider. But I can tell you there's guys like Richard Kodalski, who I highly respect, who endorses spray foam. So it's mixed opinion out there.
Great, thanks, Larry. Great answer. Next question we just got in the chat from Stephen. He said, question regarding modular homes and the new energy requirements, step code requirements. How will this affect the CSA approved modular system?
Yep. Question for me, a non-modular builder?
Yeah, I guess, yeah.
Yeah, no clue.
Okay.
Sorry, Stephen.
Yeah. We'll wait a couple more seconds, but no other questions have come in yet.
I'll say Luke Dolan. We've used Luke on many of our homes. Thank you, Luke. There's an energy advisor who likes to be involved early, and we've used Luke Dolan from Capital Home Energy many times, and we do this IDP with Luke.
Okay, looks like we can get going on to Nicholas's presentation, and then if there's any questions for Larry that come into your mind, just feel free to enter them in the chat box, and we can have a big Q&A at the end as well. So Kevin, did you want to introduce Nicholas?
Yeah, I will, and I just want to highlight. I think I certainly learned a lot from Larry today, and I think a few of us have probably been in a room where it may have been cooler or warmer than anticipated. And I think as we start designing higher into the upper steps, I think it's key that what we want to avoid is as we experimenting or trying with new mechanical systems or design strategies, that we do have practice this IDP to avoid those consequences that we're highlighting here that Larry noted, that uncomfortable customers, where that's going to probably result in a variety of callbacks and disappointment and those kind of things. And I think that's really key, that just kind of sitting together in a room at the first outset can avoid those problems 1 or 2 years in the future. So thanks, Larry, for really highlighting that to us and sharing your experiences. I'm gonna go over here. This is okay. Oh yeah, we're learning a lot of cool stuff around this Halloween season. So practice IDP or to avoid spooky scenarios. Okay, so I'd like to introduce Nicholas Bell. He's going to talk about his net zero, and yes, I do mean a fully net zero home. And I'll quickly highlight what that means. It means that this home was designed to a standard of energy efficiency such that The deficit in energy needs, or what you do need to power the house, which is probably around 80% lower than the base case, whatever's left over, you're able to generate by on-site renewables, or typically solar PV, such that at the end of the year, you end up having a zero sum of energy used in that building. Nicholas Bell has a background in urban planning. He's done many different types of work in the building scope, from renovations to custom homes to tract homes. With his current company Qualico, he's done 1,800 Part 9 homes, and 350 of them were step code homes. So he's clearly very experienced in step code. And as well, the home he's building now will be the first official CHBA, Canadian Home Builders Association, certified net zero home in the township. So it is a milestone within that compliance framework. So please welcome Nicholas Bell to talk about the net zero, his net zero home, and his experience with IDP. So Nicholas, I'll let you go ahead and you can share your screen.
Nice. Thank you so much. So I hope everyone can see what I have up here now. So yeah, as mentioned, my name is Nicholas Bell. I'm a project manager at Foxridge Homes BC, which is a division of Qualico Developments. For people who may not be familiar with Qualico, Qualico is one of the largest fully integrated privately owned real estate companies in Western Canada. We have offices in Winnipeg, Regina, Saskatoon, Calgary, Edmonton, and Vancouver, as well as offices in Austin, Texas, and Dallas-Fort Worth, Texas. And Foxridge Homes BC is the single-family production home builder business unit operating within Qualico Developments, Vancouver. So with all that, I'm here today to discuss this net zero home and a few other things. Qualico formed an internal sustainability group a few years ago, of which I'm a member, and with the support of our executive leadership team, we have taken the initiative to build a number of net zero or net zero ready homes throughout our various business units. As Kevin mentioned, Foxridge Homes BC has elected to build a full net zero ready home, but we have also elected to make the house step 5 of the BC Energy Step Code. And basically the topic of the build came up a few times through my conversations with Kevin and also Robert Baker, and they invited me to come and speak with you about this. So we'll go over specifically how the step code has changed how we build as a tract builder, and also our approach to the net zero home that we're building. So a little bit about me, has already kind of gone over this, but 11 years experience with construction, project management, and urban planning. I'm the project manager of Foxridge Homes, and we've built approximately 1,800 single-family and non-strata row homes, and since 2019, around 350 of them have been under the BC Energy Step Code. So from a production home builder perspective, which is what we are, I was asked to discuss how the BC Energy Step Code has actually impacted our homes, and generally speaking, we've adapted pretty much the same way as everyone else. So more insulation, higher efficient mechanical systems, tighter building envelopes, better windows, and really diving deep into our plans and specifications and design considerations. What is different from a production home building perspective than, say, a custom builder or one-off builder is that Foxridge Homes doesn't necessarily look at individual homes, but we plan for an entire subdivision at any given time. And our typical subdivisions range from 20 single-family homes up to 100, maybe more, and our construction schedules can span multiple years. Whenever there's a code iteration or a step code change, or when we're looking at a new subdivision, internally we have our IDP process, and we come up with a specification that will work for that project and all of the homes that will be built within it. So what you see here, this is a fairly typical subdivision of ours. This is phase 3 of our Westbrook project, located at 204 Street and 76 Ave in Langley. So for us, when planning for a subdivision like this, we complete the typical new project due diligence, looking at zoning and bylaw compliance and market research and the building and cost feasibility of the project as a whole. And where the step code has come into play is we have to be very focused on things like the lot and building geometry, the lot orientations, and the service depths, because they can have a significant impact on our energy model for the home. So we review the project as a whole with our consultant team. We go through their input, our past experience relative to the houses that we're wanting to build, and then we finalize a specification that will work for all of the homes in the subdivision. And what we really try to do is minimize any lot-specific changes in order to provide consistency with our trades and site staff and our clients who purchase within these subdivisions. Looking at things from a construction perspective, our primary focus with the step code was airtightness. The airtightness approach worked particularly well for our homes all the way up to step 3 and step 4. We really first started looking at blower door testing in our homes back in about 2014 when we were kind of dabbling in EnerGuide labeling and a few other things, and we started taking a firmer response to it with the adaptation of the step code. In 2018 and 2019, our average air exchange rate was about 3 at a mid-test, and we knew that we still had lots of room for improvement. So over the years, what we did is we tested a number of different building products. We settled on an exterior air barrier system, so a taped and sealed weather membrane, and this approach has made us comfortably achieve air exchange rates below 1.5 air exchanges, and actually quite a few of our homes are scoring less than a 1.2 air exchange at 50 pascals, with our best, I guess, air exchange rate of 0.80. So in order to approach these scores, we've really had to rethink about how we approach quality control with our trades. So we needed to review our contracts, our scopes of works. We invested a lot of time in training with our trades just on what building science is, how the home works as a system. And we also invested quite a bit of time and energy with our site staff, making sure they were fully up to speed on what all these requirements were. In order to make everything work, again, from a production perspective, we had to make adjustments into our construction schedules and account for quality control checks and our mid and final air tests, which we do on every house. And as an added layer, we actually went out and purchased blower door systems ourselves and theatrical fog machines as a way to smoke out our houses prior to our blower door tests. So what this does is allows us to review or pre-review the continuity of our external air barrier and correct any deficiencies prior to our pre-drywall blower door tests that are provided by our energy advisors. And this smoke out that we do, it doesn't give us an air exchange rate. It's just strictly a visible thing that we can do so that we can address any issues before we do our actual test. And aside from air tightness, we also implemented improvements to our windows and insulation and mechanical systems in order to meet the current step code requirements. We reviewed our house plans. We started tweaking them a little bit, making them a little bit more efficient. And to date, we have about 34 houses that have outperformed the base step code requirements and have achieved step 4. So jumping over into our net zero house, Kevin mentioned this briefly, but by definition, a net zero home is a home that produces as much clean energy as they consume annually using on-site renewable energy systems. And there are 2 tiers to the CHBA net zero labeling program, the first being net zero ready and the second being net zero, with the only difference being a net zero ready home doesn't have the on-site renewable systems installed, but everything else is the exact same. So when we started digging into this project, we decided that firstly, we wanted to go net zero, including our on-site renewables, which we chose to be solar. And secondly, we wanted to meet step 5 of the BC Energy Step Code. And this is important to bring up because you can actually meet net zero ready and net zero labeling with a step 4 house. But because we were already achieving step 4 in some of our other homes, we decided to push for step 5. And with all this in mind and the lessons we learned in our other subdivisions, we kind of set a basis point and started developing our plan with our consultants for this net zero home. A big test for us was to see if it was even possible to build net zero using our conventional building practices that we use in all of our other homes that we build. And as a production home builder, costs are always a concern, but so is scalability. We want to make sure that anything that we're doing to this house could potentially be scaled up for larger use in a subdivision. So we didn't want to make too many changes if at all possible. For this home, we did decide to keep it fuel agnostic, so it will use natural gas and electricity. And we wanted to make sure that the home fit the character of our neighborhood. So with an architectural style that fits the rest of our homes, and in this case, it is a farmhouse or craftsman architectural style. And what we ended up with, as you can see in the rendering here, is a 3,235 square foot home, 5 bedrooms, 4.5 bathrooms with a full in-ground basement and a 543 square foot secondary suite. So before we started digging too much into the building design, we needed to select a lot that would actually be suitable for the build. We reviewed the lots that we had, and we decided to select on a lot in the second phase of our Westbrook subdivision, located at 20550 77B Avenue. This lot was ideal for us because it was nice and flat. It had good north-south orientation, simple lot geometry, and it was actually a little bit wider than our typical lots. And these details for us were important because it allowed us to fit a home on the lot that could maximize the passive solar heat gains from the south-facing rear yard, and also the north-facing elevation would have a natural reduction in glazing due to the overhead garage door. The wider lot also allowed us to maximize our south-facing roof area for our solar array, as well as take advantage of passive cooling opportunities through the placement of deciduous trees along the rear property line. So with the lot selected, we started digging into our design and pre-construction process for the home. On a typical project, creating a new house model for us takes about 3 weeks to produce a permit-ready plan set from start to finish. With this net zero home, because there's a lot of additional people involved, as you can see on this slide here, and as Larry discussed earlier, this took longer than what we were expecting. It took us about 2.5 months to iron out all of the details. Part of this is because there's a general learning curve for the added complexity of meeting the energy targets of the house. And we did spend quite a bit of time sourcing and pricing out options for both the envelope and mechanical systems, but overall it was longer than expected. And so these next few slides will go over some of the evolutions and details that we incorporated into the plan from the original concept to the final plan set, and how things basically changed over the pre-construction and design process with all of our different consultants. This process that I'm describing here, it isn't necessarily specific to our net zero homes. We do this to some degree for every house model that we create, but because of the high energy targets that we have on this house, we spent more time, and it was a more involved process than our regular homes. So what you see on the left is the original main floor concept prepared by our designer. We used it as a starting point. The lot itself that we chose for the net zero home is an R1A zone lot. So there were some bylaw considerations that we needed to take into consideration, but otherwise the initial floor plan looked pretty similar to most of our other front attached garage homes in the area. But looking at it, there were a number of issues that jumped out right away, and it would have made it difficult for us to meet our energy targets. So I've highlighted them in yellow here for you. The first one, as was discussed earlier by Kevin, the building geometry was just overly complicated. There's lots of corners, there's lots of projections. The second was the upper floor setbacks that were originally proposed are again overly complicated, making a difficult structural layout. And our designer had also proposed a double floor height great room, which, although it is a popular feature in our standard homes, it does reduce the overall floor area of an already restricted house size due to the zoning, and it increases the volume of the house relative to the floor area, making it overall less efficient in the building model. So What we ended up doing is we moved a bunch of things around. We simplified the building layout, the structural design. We stacked floor areas where possible, and we ended up with the final main floor layout to the right, which is much simpler, and it was able to meet our energy targets. And here we have the front elevation, original concept versus the final. And upon a quick glance, the homes do look fairly similar, but there are some distinct changes that did make it easier for us to achieve our targets. So highlighted in yellow here again, mainly we reconfigured the main roof structure to allow for more roof area to the south-facing sky. We realigned the upper floor setbacks to match the main floor. That would allow us to simplify our build and the building envelope. And we reviewed all of the window sizes throughout the home, making small changes throughout to help optimize our energy model. So while we were working on the design considerations and all the revisions were being reviewed, we were also busy reviewing our specifications for the project. As we'd mentioned earlier on here, we really wanted to make sure that the home wasn't too different from our typical houses based on the successes that we've had with our other builds and our trade's familiarity with the overall process. So what we were able to make work on this home was just a standard 2x6 framed exterior wall, 24-inch on-center studs with R24 batt, so no external insulation, a fairly standard R60 blown in the attic, our standard exterior taped air weather barrier, and a minimum target of a 1.0 air exchange at 50 pascals. Where we needed to start deviating from our home was the below grade wall system. And we had opted to go for this home with a 2-inch rigid plus a 2x6 R24 batt frost wall and a 3-inch under slab insulation. So far, I've mentioned the south-facing rear elevation on this home a few times, and one big topic that does come up with passive heat gain is overheating. Overheating is definitely a big concern for very high-efficient homes if they're not designed properly. So we took this into consideration and we worked out with our window supplier and our energy advisor to come up with a window package that provides us with a 0.98 USI or better rating for the window's efficiency with a 0.26 solar heat gain coefficient. With our experience in our other homes and that of our energy advisor, this 0.26 solar heat gain coefficient is a really good balance for a window between allowing passive heat to enter the home while also keeping it out during the hot summer months where you wouldn't want that gain. We're also looking at our mechanical system. We looked at a number of different options. As Larry had already mentioned, the first step whenever you're looking at this is you have to complete your F28012 room by room heat loss analysis. This is a technical requirement for the net zero labeling program, but it's also something that we do for all of our house models that we build. And we want to really make sure that we're accurately sizing the mechanical systems, not only for this net zero home, but for all of our homes. And when a house is super efficient, we'll call it, with a very tight building envelope, and it can be very surprising for some mechanical contractors to see just how small the heating equipment can actually be. And oversized mechanical equipment, it's very, very common. It's costly. The systems themselves, they start to cycle, they underperform, and they make a generally uncomfortable home to live in. So with all of that in mind, after we completed our heat loss calculations, we decided to go with a heat pump for our primary heating and cooling system. On this home, the heat pump is a 19 SEER variable speed unit with a 24,000 BTU capacity that is rated for cold weather. Now, a cold weather heat pump in BC, it might seem like a bit of overkill, particularly in our climate zone down here, but it's important to remember that heat pumps generally are rated at 8 Celsius, and the temperatures at around -8 can lower the efficiency of a heat pump to around 60%. So you can bypass some of that efficiency loss by upgrading your unit to one that is rated for cold weather, and cold weather units maintain their performance and are rated at around -15 Celsius. For our water heating, we really wanted to keep our 96% efficient tankless natural gas water heater. We use it in all of our homes now. It's a very good unit. It is very efficient, but we also wanted to provide an auxiliary heating system for the home in the event that supplemental heating was necessary above and beyond what the heat pump could offer. So we elected to install a hydronic air handler onto the tankless water heater to create a combination domestic hot water space heating system. And what this setup allowed us to do is maintain only a single gas burning mechanical appliance, which we're pretty happy with. Also for this home, as we were designing the upper floor, we wanted to make sure that we were positioning our bathrooms in such a way that they could be easily drained into a domestic water heating recovery system, which we will be installing. And we opted for a solar array for our on-site renewables, and in this case, it is modeled at 14.1 kilowatts. So, the performance metrics, the thing that everyone is very interested in when it comes to these sorts of homes. Here you can see some of them that we've pulled from our compliance reports that we have. As you can see, our MUI, our TEDI, and our air exchange, they are all in compliance with the Step 5 requirements, which we are excited to see that we were able to do that. Additionally, greenhouse gas emissions, it's a bit of a topic right now for a number of people. So we looked at the modeling metrics for this house as well. And with the specifications and the changes that we made to this home, it is expected to have a 79% modeled reduction in greenhouse gas emissions relative to a code minimum house. And also looking at the energy source and consumption for this home. Again, these are modeled numbers, but the home is set to consume 81% less natural gas and 12% less electricity than a code minimum home. So, what did we learn through the process? First of all, if it's your first time pursuing Step 5 or a net zero labeling program or any other highly efficient labeling programs, just be prepared for more revisions and changes than you may expect. As a production home builder, building this house speculatively, we did have the freedom to make changes and optimize the home ourselves, but obviously, if you are working with a customer in a custom environment, you need to get them involved in the process right away. There are a lot of trade-offs that you have to review and decisions that have to be made when trying to optimize these highly efficient homes. And less efficient design choices are completely possible, but they will come at a cost premium if you don't plan for them ahead of time. You really want to get your trades and consultants involved in as early of the process as possible. Larry mentions the good old days when you could buy a set of house plans and build it and move on, and it's really not possible now. You really have to get everyone involved in this, make sure that everything is going to work down the road. Otherwise, you're just putting yourself behind the 8 ball right away. And don't forget to educate yourself on these things. So relying on the experience of others is great. It's a good way to learn, but you should also be knowledgeable about the products that you're building. And if you don't understand how highly efficient homes function, I can imagine it would be quite difficult for you to explain it to one of your clients, and especially a client who isn't in the industry. When it comes to the flexibility of your mechanical system, just be open to changes. A lot of mechanical trades may not be fully up to speed on these very highly efficient homes. It is a known problem in the industry right now. But starting with your F280 or your heat loss analysis, just make sure that you're sizing the equipment properly and be open to suggestions from your consultants and particularly your energy advisor. Part of this house for Foxridge was not only to achieve Step 5 and our net zero label. We also reviewed a number of different green building products that we could incorporate into it. In order to try and lower the building's ecological footprint as well as its embedded carbon. Embedded carbon is something that people are paying a little bit closer attention to right now. And one of the upgrades that we actually did for this home, in addition to everything else, was we changed our concrete mix to a high strength, low carbon concrete that's rated to have about a 50 to 70% less embedded carbon than a traditional mix, which we're really excited for. It worked really, really well. But this isn't something that's going to show up on a report for us. It wasn't a requirement for step 5 or net zero. It's just something that we elected to do. So the home itself, it was planned and designed under very ideal conditions. We purposefully selected lots and we designed this house in a very specific way in order for us to achieve step 5 and our net zero label. And what we put together for this project, it might not work for another, which is unfortunate, but at least it gives us a very good starting point for the rest of our homes. It's unlikely that even if we took this exact same house and changed the orientation from north-south to east-west, that it would meet the same energy targets. So you really have to be careful when you're planning these sorts of homes to make sure that you are fully understanding how everything works. But that said, this house does give us a good starting point should we look at building other net zero homes in the future. And other than that, I just wanted to say that there's a lot of different options when it comes to building a high performance home. There's lots of different pathways for success. People can do ICF, people can do outboard insulation, people can do all sorts of stuff. There's lots of really great products out there. What I've described here, this worked for us on our house. So far, things are looking great. We are expected to complete this house in June 2023, give or take. So we're very excited to see how the project develops over the next few months. And thank you very much for inviting me to speak.
Thanks so much, Nicholas. That was awesome. I think we learned a lot, and that your net zero house is remarkably impressive. And I think you'll be able to achieve that by a lot of forethought, a lot of planning, and a lot of dialogue with a lot of different stakeholders as a part of that process. And I think it's really critical, and you mentioned this, and as well as Larry mentioned this, is to conduct your heat loss calculations and really speak to the right consultants like your mechanical contractor to maximize your outcomes. Where otherwise, what we've seen and heard that kind of rules of thumb are still kind of used when around designing mechanical systems. And I think as we go into step 4 or 5, net zero, energy ready, net zero, that practice can probably end up being a liability, as noted, with oversized systems, dramatic cycling, and potential early failures. So thanks so much for highlighting that. I think this is one of the very first times that we're really, really on time, Sarah and Gina. I think that's great. That's really lucky for us. So maybe I'll pass it over to you, Sarah, to facilitate a variety of questions that I think shown up in the chat. And I'm not sure if there's any hands up or not, but I'll pass it to you.
Sounds good. Okay, yeah, it looks like we have 4 questions to get through right now. But yeah, if you have a question, feel free to put it in the chat or do the raise your hand feature, and then I can unmute you. Okay, first question. We had someone ask, can we tour your net zero home, Nicholas?
That is something that we're working out with our marketing team right now. So we are figuring that out kind of as we're moving forward, and more information will be available through the Foxridge social media as it comes up.
And then I guess this could be a comment for both Nicholas and Larry, or a question for you. Does anyone have a comment on aero barrier? Maybe Nicholas or Larry, you can go first. You unmuted.
Sure, yeah. Yeah, aero barrier is becoming quite common now. Now, we haven't used it. Our preference is trying to train our trades to hit the air tightness targets without using aero barrier. The one element that worries me is there's no long-term studies on aero barrier, and so how will it perform in 20 years or 40 years? The products that I like to use, we're using on our homes, tend to be they've been tested in the factory. Like when we tape our windows, we don't do the rod and caulk. We tape them. In the studies, they've been in the testing facilities to last 100 years. We just don't know that about aero barrier. But I will say this: there's a lot of really good builders who are using aero barrier, and they're hitting these really sub passive house levels, hitting 0.2, 0.1. So those crazy numbers are coming from the aero barrier.
Thanks, Larry. Nicholas?
Yeah, I'll kind of, I guess we have a fairly similar opinion on it, Larry. There is some unknowns about the product. It is fairly new. I do know a few builders who are using it. It does work particularly well in a multifamily environment where the party wall can be quite difficult to seal with traditional construction materials. But my preference is to try and just work on the quality control end of things and see how we do. Also, just in relation to the super air tightness that it can provide, there is a trade-off between going from like a 2 air exchange to a 1 air exchange versus going from a 1 to a 0.5 air exchange. So the overall benefits of reducing it to these super low levels might not be as impactful. So financially speaking, it might not be the best solution. But again, it's completely up to how you decide to model your home. So there's tons of unknowns about that. So it's really a personal choice.
Thanks, Nicholas. Okay, the next question that we had at 1023 was, does your net zero home include power for an EV? And if so, how many kilometers per year? So answer that how you would like, Nicholas.
How many kilometers per year? That's a great question. I think you'd have to direct that to the vehicle manufacturers. But we are including an EV charger. That is a requirement within the township bylaws. So there is a level 2 charger in the garage. So I hope that answers the question.
I think the question maybe had to do around like the net zero like certification of it, and if that includes power for an EV. Yeah, Kevin, if you want to jump in.
Yeah, just on that, and Nicholas, you can add to this, but for net zero certification, this is for operations, it doesn't include, as far as I understand, the charging of a vehicle. So you can get the net zero certification primarily by offsetting operational demand.
Perfect. Thanks, Kevin. And then at 1032, we had a question for Nicholas. Who is doing the mechanical design, contractor or mechanical engineer?
So this is a Part 9 building, so we are using our mechanical contractor as well as the mechanical manufacturers. We're relying on them to provide some input as well, and our energy advisor to come up with the mechanical system for this home.
Thank you. Next we have, how are the different districts, or I guess municipalities, dealing with houses that don't meet the proposed step? So I think this is maybe a question for Kevin.
Yeah, thanks. So let me read that question here. Our different districts dealing with houses that don't meet the proposed step. Jody, if you could maybe elaborate a little bit in the chat, but if I'm reading it correctly, if it's how do different districts deal with houses that aren't compliant with the municipality's bylaw, if the municipality is requiring step 3, 4, or 5, or whatever it may be, if you do not meet the proposed step at final, you will have challenges getting occupancy. If that's not your question, go ahead and rephrase it in the chat.
That's how I understood it as well, I think. Next we have, I guess this is a question for both Nicholas and Larry. Have you ever designed or built a step 4 or 5 home in colder climate zones than Vancouver, such as the interior of BC?
Not me.
We haven't either. We do have, as I said, a number of business units working out of colder climates than Vancouver, like Edmonton. So we do know that it is challenging to some degree, and it is also very different from what we have to do down here. So I would rely heavily on your energy advisor to direct you on the best way to go about building a house in colder climates.
I'll step in here just a little bit. Yeah, thanks, Carl. So we focus here on the building industry operating in the township, but the knowledge certainly goes farther than our boundaries. I'll just direct you to some resources. Maybe Jean, if you could find some of the step code resources that Carl can, or others that build more northern than here. There's a lot of resources on what you can do for climate zones outside of climate zone 4, climate zone 5, 6, 7, etc. It's a step code changes in different climate zones, so the targets are different, and the reports that are out there that will provide other types of strategies to help meet those steps.
Okay, the next question that we have, which looks like Larry might have already answered in the chat, but Henry says you tuck tape your windows. I've never seen that. That's interesting.
Yeah, no, and I see Aaron's asked a question about best methods of installing ceiling windows. I'll reference the ceiling because that's come up before, is what we're using now. I used to run rod and caulk for many years, but we're moving towards the taping because I think that's going to give better long-term results. We use a product that is from either Sega or 475 High Performance Building Products. And I do show some of this on my social media, so feel free to take a look. You got to go back a month or two, but we've been doing the taping for long-term results.
Okay, thanks, Larry. Nicholas, did you have anything to add to that? And yeah, kind of Larry also answered, like, what's the best method on installing and sealing windows, trying to meet step 4 and 5?
No, nothing really to add. It's really whatever works for you. Rod and caulk works, taping through different high performance tape works as well. If you're not familiar with a lot of the details that might be specific to sealing up a window, I would encourage you to, do some research on it yourself, maybe reach out to an envelope engineer and they can drop some details for you.
Thanks, Nicholas. I realized I missed a couple of questions back in the chat. Someone had asked for a list of solar consultants. So maybe we can have, because we have our Q&A document that goes out after the webinar. So if there's any, I guess, suggestions from Larry or Nicholas on solar consultants, they can add them. But I think as the township, we don't Kevin's nodding his head. Yeah, we don't suggest businesses for you to work with. Then we had one at 10:36 from Jing. So how is makeup air handled for the net zero house?
Well, it's all taken into consideration with the mechanical system layout. So we want to make sure that the makeup air system is sized adequately for the house itself. I'm not sure if there's anything more specific that the question is referring to.
No specification there.
Yeah, I'll just agree that when you do your F28012 calculation, your mechanical contractor is considering things like the air tightness, the hood fan size, what appliance you have, any naturally aspirating appliances, and then you have to include makeup air. This will be more critical as we get tighter.
Great, thanks, Larry. We're reaching, I think we're at the second last question here. Oh, another one just came in. But would you ever consider building, I guess, the net zero home fully electrified? I guess a question for both of you, going fully electrified?
Yes, yeah, I would love that. You know what? There's two sides. One is affordability and gas. There's something nice about the affordability you get with gas, but I also know that I have this air quality monitor in my home, and I remember it went off, red lights. I phoned home. My daughter was so I phoned home. My daughter said, "Did you put on the stove?" are you cooking? And she started laughing and looking around like maybe there's cameras in the house. And she says, well, how do you know? And I said, well, the air quality monitor. Now, she didn't have, it's typical of my children, they didn't have the hood fan on, and that should have been on. But electrification is exciting. I think it's exciting for air quality, but we have some infrastructure issues, especially as we have a lot of electric vehicles coming onto the market. It's not as simple as just going electric. So that's what I'm hearing at the national level is we have to push slowly because electrification is going to be hard to implement if everybody moves that direction right away.
Thanks for that, Larry. Nicholas?
I would agree. I think that there is some merit to full electrification. For us, it's just not something that we wanted to do on this house. We wanted to provide the gas hot water heater and provide a supplemental heating system for the home in addition to the electric heat pump. But grid sizes and constraints and also the services that would need to be pulled into the house to make it fully electric with all the other bells and whistles is a bit of a concern for us at the moment.
Thanks, Nicholas. We have a question from Josh. He says, as an EA and home designer, I completely agree with the concept of IDP, and I push for this on every project we work on. However, it's more often than not, especially out in the valley, Fraser Valley, that a homeowner doesn't have a builder in the planning phase, let alone a heating contractor. Larry or Nicholas, do you have recommendations you can make based on your experience to help encourage people to get builders on board earlier?
Yeah, I can step in. I think designers and architects are going to have to start educating the homeowners because I don't think they want to design a house, get to the end, find a builder, find out that they can't meet step code. That's going to be cost prohibitive. So I would say that if designers and architects are not doing that, you do that, you make that mistake a few times, you're going to start insisting on it.
Yeah, you nailed it on the head, Larry. It's going to be something that you just have to do moving forward.
Yeah.
Okay. Then we had a question for Larry from Brandon. So he says, Larry, with an exterior EPS application and dew point outboard, what is your preference of location or method for the building wrap?
So I like the, we call it warm building wrap. So I like to put the building wrap on, then the EPS goes on. Murray Frank actually has a new concept where he's using 2x4 wall, because we don't need 2x6 for structure, 2x4 wall, 3/4 inch plywood. That plywood now, if you know, the fasteners don't have to hit studs to go straight into 3/4 inch plywood. It's going to improve your seismic resilience. But then he's putting on about 5 inches of EPS. So the dew point's outboard, which is always going to be fantastic. Keep the dew point outside of the wall assembly. That's my preferred. EPS is a nice way to go because it's more permeable than XPS. I like rock wool, but there's issues, or comfort board. There's issues with keeping it perfectly flat as you plane across the wall. So I think that answered the question, and I gave you a little extra.
Thanks, Larry. Okay, I think it's 10:56 and the questions have stopped rolling in. So Kevin, do you want to wrap it up? And I'm just going to post the survey link in the chat and also the link to our education page again. And I'll also email out the survey link as well, so you'll have that in your email.
I should say one thing as well. The PDF of my slides has been sent to the township. So you're going to, all that information you're going to get along with the links, they'll all be on that PDF for you.
Great. Yeah, both Nicholas's and Larry's presentations will be on our webpage within the next week or so. Thanks. Kevin?
Okay, great. Yeah, thanks so much, Larry and Nicholas. This was, just gonna show a slide here for your credits. Yeah, Larry, Nicholas, thank you so much for your presentations. I think these were really, really awesome. And I think equally as impressive was the amount of questions that came in. I think your lectures, your presentations really inspired our audience to dig deeper and ask those questions that's going to help them continue operating. Thank you so much for all those great answers. This is probably one of the more active or engaging workshops we've had, and it seems to be a bit of a trend. So thank you so much. This is what the point of the Builder Forum series was all about, was to have dialogue with each other. Thanks so much. There's just so much I think we took in today, and really awesome pieces here. I think I just want to highlight one or two pieces that we've seen here. One of the later questions was focusing on electrification and some kind of challenges or where we see that going. I think that's really a topical and important thing to talk about with your consultants and your stakeholders. We saw with Nicholas's net zero home, it is the first one I really want to highlight, or CHEB certified one that we've seen in Langley. They were able to make that with using natural gas, which is very impressive, and they were able to meet a GHEI target of 3, which will happen to be those who participate in the consultation of the new BC updates. Will see that is the low standard, which is very impressive, which the BC anticipated the low standard to be met with 0 natural gas systems. So this goes to show that through modeling, through dialogue, through a spectrum of different design choices, you have a very flexible arena to be able to build your house or design your house and meet different outcomes. So again, going back to that IDP concept, is to speak with your consultants and stakeholders very early to indicate what you want. And in this case, Nicholas was able to have a natural gas running in his house where it would meet a low standard, which is very interesting. And as well, if you're worried about operating costs or other pieces to your build, if you do target net zero ready or step 5, your demand will be so much lower. And if your air changes are very, very low, again, it will reduce your electrical demand on your system. So I think there's a lot of interesting things you've seen. Again, just highlighting to speak to your consultants and stakeholders. I'm highlighting here credits. I just want to make a quick note. I do know that there are some technical difficulties with any workshop, and that's okay. If you did have to log in and out a few times, that will impact kind of how we track your attendance and therefore credits. Just bear with us, communicate with us and your association to get the full credits. Again, thank you, Larry Larry and Nicholas, for your lectures, and thanks everybody for all the dialogue. You will get an email from us with the full lecture, and as well, I want to highlight you will get a link for a survey. Please participate in the survey, share your thoughts, what worked for you, what didn't, what you want to hear more of, what you plan on doing, what you plan on trying is all really important to us. Thanks again, and I think I think we're just on time, so that's perfect. So thanks again, and we'll see you for the next session. Thanks again, everybody.